Good evening, Sherry. Coordinators, please note that next resource person has already joined. Sherry, we have just winded up our previous session and we'll be starting it by 8:15. So, meanwhile, I think,
Yeah, sure, sure.
yeah, we can wait for 2-3 minutes so that they can just refresh and come back because it was all 1.5 hour sessions. We have given a 2-3 minutes break.
Sure, sure.
We'll start the next session.
Okay, madam.
Shall I start? Hello.
Let us start the session. Mr. Sherry Thomas, a renowned expert in industrial IoT, analytics, and machine learning, will lead the second session of the FDP on data science for decision making. With his rich experience as Director of IoT Solutions at Gadgeon Systems, Sales Manager at ITT, INC, and Amphenol FCI, he brings a unique blend of technical expertise and business acumen. Mr. Sherry's impressive credentials include an MTech in Data Science, MBA in Marketing and Finance, and BTech in Mechanical Engineering. He is a dedicated educator and researcher, passionate about sharing knowledge and exploring organic farming. We are ready to gain valuable insights from this session, sir. Welcome.
Thank you. I hope my sound is audible.
Yes, sir.
Yes, sir.
Yeah. And I'm facing some challenges here with the network. So kindly let me know if the connection breaks in between. Maybe elsewhere, ma'am, you can give me a call, give me a ring if something goes wrong. And so, good
Sherry, are
evening,
you able
everyone.
to share the PPT?
Yeah,
Okay.
I'll just share it. So good evening, everyone. So, like the discussion mostly it is going to revolve around what the industry is expecting, or rather, from an industry perspective, like how decisions can be enabled with the help of data what they collect from their industrial systems, and how can that enable much meaningful, much insightful decisions. That is what I will be covering mostly about. And it is going to be a very light session, so you can just relax and just follow. So I hope my screen is visible now.
Yes, sir.
It's visible, right?
Yes, sir.
Yeah. So this will be the agenda for today. I will just talk about the data, what is available in the manufacturing sector and where it is available.
Due to some connectivity issues, Sir left temporarily from the meeting, but don't feel bad. Sir will rejoin very soon.
Hello.
Yes, sir. We can hear you.
Um, did I break in between or?
No, you can continue, sir.
So, see, what I talked about was the lot of data which is getting collected in the
Can you
manufacturing
please,
industries nowadays.
excuse me, sir, can you please share the screen also?
Oh, it's not shared right now. Okay, one second. So now it is visible, right?
Yes, sir.
So see, the challenge what the modern facility facing, it's not the lack of, it's actually the huge amount that they are generating. Uh, so mainly it is from all the factories nowadays are automated. So the the programmable logic controllers or the PLCs.
And sorry for the inconvenience. As the sir said, he got some connectivity issues. Sir will rejoin soon.
Participants, please wait. Sir will join soon.
Please stay in the session as Sir got some connectivity issues. As already instructed, for getting the certificate, you have to maintain a minimum attendance percentage of 80, and also you have to get a mark of 70% or above for the final assessment.
Hello.
Yes,
Yes,
it's
sir.
audible.
Yeah, so yeah, very sorry, and I had some difficulty in getting that connectivity back.
It's okay, sir.
Okay. Um, so let me just share my screen once again.
Okay, sir.
This is visible, right?
Yes, sure, it is visible.
Yeah. So I think my conversation was missed out. So anyway, this see what I was trying to tell was the problem these industries face is mostly the huge amount of that data which actually they have. It's not that they don't have data, but they have huge amount of data. But the actual problem is they are not using this data properly. And majorly the challenge lies in the transforming this raw data so that they can make some actionable insights from it. And another problem is data is residing in silos. So getting this data to a central place and doing the analysis, that is actually a difficult job in most of these industries because most of their automated lines uh, that does not connect to another automated line. So it's all in silos. That is one problem which people face in industries. And this is actually a typical scenario in a factory. So you can see a process area one where a PLC or an IO module, it collects a lot of data from maybe it's from a digital input, maybe it's from some sensors or meters. And you will have some other area where exactly a similar kind of setup with some other kind of sensors connecting to a PLC and communicating. All this data will be there available in PLC, but unless otherwise you establish a connectivity there, get it into a central repository, the analysis of the data which is coming out from these PLCs will be extremely difficult. And in an area 3, you have a CNC machine itself, which do have controllers, which also allows communication, but it's seldom used. So in this scenario, like, when you get all these things connected, and when you establish a network, and if you can get all this data to a central position, you can do some stuff out from it. Okay. And the typical data sources, what's available in a factory, typically it is the sensors for the temperature, vibration, current, or pressure, whatever it is. And then you have these PLCs. Most of the automated lines, it's been controlled by PLCs and the SCADA systems. So many of the control events, set points, the machine statuses, everything will be captured in these PLCs. And then you have the production data. It can be something like a cycle time, the throughput, the count, all these things that will be available in your ERP system. The quality records, some of the companies, they do have quality embedded in their ERP itself, or some of the companies, they have a quality system separately. So all their inspection defects and all those things will be there. And then the maintenance systems. So the most of the companies have got a separate software for the maintenance logs. So the service history, the breakdowns, repairs, whatever they have done, all those things will be captured in that separate the maintenance software. So you can imagine the complexity lying there. See, some of the data, it's only up till the sensor. Some of the data, it's in the PLC. Some is actually on the ERP. Some other things are on the quality system. The maintenance logs are there in the maintenance management systems. Okay. And then the material flow, the inventory, the movement tracking, and all those things, the RFIDs and all those things are there, extensively used in industries. All these data are available, but getting all these things into a single place and getting meaningful insights from that, it's going to be a big challenge. Okay, and if at all you need to do some analytics in the manufacturing, and this is very, very elementary kind of thing, which many of you would have already studied, or many of you would have already read it out. Any analytics that needs to be done has got four distinct phases. So the descriptive, the diagnostics, predictive, and the prescriptive kind of analytics. So we will see one by one. And this is basically what has happened. If you have a data, you just analyze it and find out what really happened. And I can just show you some examples where it is not that kind of easy when it comes to the raw data and getting some insights from this data about what really happened. So we can just explore it, some manufacturing examples. So before going to that, let us just understand one KPI, a key performance indicator, which is very widely used in the manufacturing industries. And this KPI is known as OEE, or overall equipment effectiveness. Okay, and if you ask me, many of these world-class companies in the sense, maybe Maruti can be called as a world-class company. So the OE of Maruti may be somewhere around 90%. And many of the best companies which you see in India, the OE may be somewhere around 80 to 90%. Not more than 90%, 80 to 90%. And many of the good companies which you hear about, the OE may be somewhere around 60 to 70%. And many big companies, they are struggling to get their OE up to around 70, 80%. Okay, and that is a challenge. And how this OE is computed, it's basically it's the product of availability, performance, and quality. So availability means you have the machines there, but whether that machine is available when it is actually required to produce something. So that is the availability metric. And then performance is you start producing something out from the machine, but are you producing it in the optimal speed? So there is a cycle time for every production from a machine. So are you producing it in the optimal cycle time? So that is a measure of performance. And quality, obviously, it's like not all the parts produced from a machine are going to be good parts. So some are going to be rejects or bad quality parts. So the ratio between the good parts to the total number of parts produced, that is going to be quality. And if you multiply all these things together, you will get the entire OEE. Okay, so now I will get you introduced to a data set. This data set has got, so this is basically the data set. This is actually a data set which collects data. So this collects data from some 5 different machines. Okay, it has got a timestamp. It has got the machine name, and it collects the status of that machine. So it has got 4 statuses: 1, 2, 3, and 4. So it's all numerically coded. 1 being the running, 2 is actually the idle time, 3 is the stop, and 4 is actually the shutdown condition. And it's collected every 5 minutes. Every 5 minutes, this data is collected from these machines, and you have the parts produced. So you can see that not in every minute parts are produced. So parts are produced maybe every 30 minutes or so, the parts are produced. And against each part produced, so you have a quality pass also is there. So 1 means quality is passed, and when the part is produced, if it is 0, that means that part whichever is produced, that is of bad quality. So this is the data set, and we talked about this descriptive analytics and the diagnostic analytics. Descriptive analytics we talked about. So we just try to analyze something out from this, and what I'm going to use is this superset. So this is the tool which I'll be using, basically because it's actually an open source. So it's very easy to download and use this superset tool. So this is the basic interface of that. So I have put some charts here, basically from the same data whatever you just saw. So from that chart, if you just start doing some analysis, if you try to do, so it is showing that 79% of the time the machine was actually running. So it was idle only for around 12%. So that means it's a very good thing that 79% of the time the machine was up and running. And if you actually see this, it has got 7 days of data. So it shows you, this different 7 different days, and the status of the machine, how much it was running and how much it was idle. So if you just look at it, it was almost same all the day, all the 7 days. It was almost the same. And if you just see this one here, so we can just do the editing and all those things here. So if you just see this one, the parts produced is here. So we'll just try to do something on this. So we have the part produced on each and every date. This much part is produced, but this does not give much information because a lot of things are clubbed here. So we will just put it into some sort of a stacked kind of thing. So we'll just put this tag. It's as a stack bar. We will just put it. So and see, and if you analyze this one also, see it's like almost all the machines. It produces in this similar manner it produces the count of the parts produced. And if you see, there's a CNC one, the first machine actually on the second day, the parts produced was actually more. So my point here is, see, other than these kind of counts and all those things, whatever you get from this, it's very difficult for you to really look at it and get something out for get some meaningful insights from it. You can just put some pie charts, bar charts and all, but it does not give you that insight about, like, how your production is going on, how the different machines, the 5 different machines, how it is performing, and day by day, how it is actually going. It's very difficult to analyze. And I have put some other things also here, like the quantity produced. So if you look at this one, here also it's the parts produced from this, it is put. So if you look at this 5th and 6th date, the number of parts, the total number of parts produced it's very less. And whereas if you compare with the running time on the 5th and 6th, it's almost the same. But the number of parts produced was actually less. So was there some problem there? We don't know. So maybe we can find it out. And if you just see the quality data, like again, here also it's like, it's meaningless. Like, if you're just seeing the quality data as such, it is just meaningless. So if you have like, the part produced data also here, so that would have been given you some more insights, like, how your the quality is performing. Maybe I can just create one more chart over there. And just see, like, so I have all these kind of the data columns here. So I'll just put the timestamp here in the x-axis, and so I'll take a time grain of the day itself, and the metric it's going to be the parts produced. So I'll just put the part produced there, and the sum of the parts produced, and then see, like, now these are the total number of parts produced. Maybe now I can put a dimension of the machine also. I'll put the dimension as machine. So now I will get this kind of a chart. I can just make it into the same stack bar. Okay, now I will just name it as the parts produced. Okay, I will just save this, and so that would have come here. So now I will take this parts produced to this quality chart. So now we have something to compare. So now we have something to compare. And again, so you don't have the values listed there. So you can just make the values. So now you can actually compare something. So this is the parts produced, and these are the good parts. So if you just look at it, the day 6 and all, it's very worst performance. Day 7 also is worst, because of many parts, whatever got produced, that is actually getting rejected. So day 5 is much better, because 79 out of the 79, 75 got accepted. So same is the case everywhere. So now you can just make out something out from here, like what is the quality, uh, if you compare with the total number of parts produced. But this also, it does not give you any such sort of bigger picture kind of thing. So maybe what you can do next is, maybe we can see some other graphs, maybe a quality ratio. This one I just created earlier, and I just put it here. So this is actually a quality ratio. It's a ratio of, we'll just see what it is. It's yeah, it's actually a ratio of good parts to the total parts produced. So this gives some kind of a picture, like where you exactly lack. So if you are, this is actually based on a shift. So it's based, we can just ignore the shift and see the full things. So I am just deleting this dimension of shift from there. So now it is, so this is your quality metric, a ratio of the good parts to the total number of parts produced. So if you just see this one, there is actually a degradation in this, a constant degradation happening on your quality. So now you have some sort of an understanding where you are actually lacking. So your quality is not good. That is one area which you need to address. So another one is actually the OE, whatever we just discussed. So you have all these things available, like your OE is computed and given here. So this OE is computed based on the number of machines, like the, various machines, how the OE parameter is, and this one is actually for the shift. And here, if you really look at it, the CNC4 or this machine is having much better performance than the other machines, and CNC1, it is having the worst performance, because there is no control at all. The box plot, if you see it, it's actually much wider. It's the mean of that box plot, it's much lower, and the other things are also not good, but it is compared to the other machines, this is the CNC1 is much lower. And if you look at this shift A, the variation in that shift A is much bigger, much wider. Whereas if you have in shift B and shift C, you have much, your range is much less, or the deviation is much less. So you have better control in shift B and C, but whereas in shift A, you don't have that much better control. But even in this one also, like, it's very difficult. You are telling that your OE is very poor, but is it because of your quality, or is it because of some other things? You don't know. So maybe what we can do is we can create another chart. So we'll just select the OE itself. We'll just select the box plot itself. Okay, we will just put the machine name as the dimension. We'll put it as the availability, we'll put as the metric here. Is the average availability which we need to put. So if I just look at it, I can just fit it side by side. So this is the availability. So where is that? So this is the availability one. I can just put it side by side to this OE and just have a comparison. So now if I see it, it's not giving much, any much better analysis. It's not giving. The availability, it is almost, it's 80% everywhere. Like CNC 3 has got some sort of a problem there. Otherwise, it's the availability wise, it's all okay because the machine was available when the production was supposed to happen. The machine was available. So it's not due to the availability of the machines that your OE is getting compromised. Your OE, if you look at it, it's only 0.4, 0.5 and all, whereas your availability was 80%. So now maybe we will just see we will edit this chart. We will just rename it as the performance. So we'll just see what. So we will cut this and we'll put the metric as performance. So now we have the picture here. So that also has come in the OE. So we just take it to this OE tab for better comparison. Okay. So now I have these three things: the OE I have, the availability I have, the performance I have. So now if I look at it, so this is where we are lacking. This is where this company is actually losing out. So the performance is very, very poor. Like, the machine is running, but it is not producing much parts. Okay, so the performance, it's only 0.4. So it's 40% performance. Here this one is 65%. This one, the mean is 54%, and here is 61. And the quality, it may not be much bad, but anyway, we will see the quality also. We will create another chart. So we'll just change the metric here. We'll just put the quality metric. It's not coming up. Oh, okay. Just without saving, I just came here. So anyway, this the quality is much better. So the quality is much better. It is 95. The only problem what we can find is CNC 5, where we have a lower quality, but all other machines, the quality is good. And here there is one outlier is here for the CNC 3. That is just one-off case. But other than that, the quality is good, the availability is good. So the only problem was the performance. So we didn't save that earlier, so we just put this performance here. Change the name to performance. Just save it as, and we'll go to the dashboard. Oh, it has come over there. So we'll just drag and drop it to the OE itself. Okay, we have this performance also here. So now this is very clear, like, where you are actually lacking. It is not your quality or your availability. It is a performance where you are lacking behind. Okay, and now it's like, where this performance is lacking. Now maybe you need to dive deeper into this and maybe understand, like, why the performance is less. So the fact which I wanted to tell you was, like, it is not that easy for you to analyze it, because now you need to have a lot of KPIs. If you need to have a meaningful analysis, a lot of KPIs needs to be there. So this KPI definition itself is a problem. So in industries, manufacturing industries, some of the KPIs used are, one is actually the OE, which we discussed right now, and another one is the specific consumption. So if you are consuming some fuel or energy or something, instead of just telling that, okay, I consume so much energy, it is told that consumed energy per unit part of production. Like, for producing one part, how much energy you are going to consume. So those are the kind of KPIs which you need to make, so that you can compare and make and understand where you are actually lacking behind. So going back to the slide. So we just saw this. So now the diagnosis will come. So we have just seen that via the various dashboards, we have just seen that the performance is the area where we need to attack. So we need to increase the performance of the machines so that we can have a better OEE. So basically, like, we need to understand why the performance is lacking. Is it because the tool which you are using for producing that in the machine, it was a worn-out tool? Is it because the operator was not good enough, so he was taking more time to manufacture? Was that the reason? So we don't know. So we need to find it out why. So that is the one which actually happens in the diagnosis area, like, why something happens. So how you can find out, like, the analytical techniques like the drill down analysis, the correlation detection, the loss tree. The loss tree is like, where exactly you are losing out. So there is a hierarchy of losses which you can actually map. So in a typical industry, it is categorized into around 16 categories of losses, and broadly it can be told as 6 losses, mainly related to the machine non-availability, the machine, the loading time, the operator non-availability, those kind of things. And no, this is exactly where you need to dive deeper into the data, like get to analyze, like once you analyze where you want to analyze further, dig further and find out what exactly has gone wrong. You need to do that in this diagnostic analysis. And then there are some the predictive analytics, like when the machine is going to fail, or kind of a quality forecasting. So maybe we can do a quality forecasting with our data itself. Like if you go back to this quality, like the good parts, whatever we produced, maybe we can do a quality thing here. So in this one itself, we have some kind of predictive analytics can be done. So now I will remove all the dimensions so that it will be easier for us to predict what will be coming next. So we can just put some predictive things into place. So I'll just put some 10 periods. So this is a simple forecasting which we can enable using these tools. So this has just put an average kind of thing. So we don't have much data to give a good prediction. So it has just produced the data based on this. So maybe we can look at some other things to get a much better prediction kind of thing. We'll go back to this. We'll take an OE itself and just see whether some sort of prediction is possible out from it. So I will just take this OE chart. So instead of this machine name, I will put the dimension as the date itself. So this is getting duplicated. So I will put the machine name here as a distribution. Okay, instead of a box plot, we'll just plot it as a line. Price of OE. So we have got a line here. So maybe we can elaborate and find it out, like some prediction whether it is possible out from this. Time grain is missing here. We will put the time grain here as a day itself. So this again, it has given a nonsensical thing. That is because it is the average OE which is getting predicted. So we'll just put because it's having many machines. So we'll just put one machine and see what is the result which is going to come. So we'll just put just one machine to see how he's going to predict it. It's not predicting. So anyway, this kind of predictions also can be enabled using these kind of things. And it's a very, very simple predictions, whatever you can do. It's not going to be a heavy kind of a prediction. It's a kind of regression kind of simple predictions you can do with this. So what all things you can predict is like the failure of the machines can be predicted, the quality forecast can be done, and the production output, the anticipate the output, how much you are going to produce, that also can be done. and the tool wear and tear, the energy demand, all this can be predicted using that. And then finally it comes to the prescriptive analytics kind of thing. So in order to have a certain amount of in order to have a certain OE, what all things you need to improve upon, what you need to optimize, which all parameters you need to improve upon. These are the kind of things which is given in the prescriptive analytics. So in our case itself, we have just seen that the performance was less. So maybe we can give a prescriptive analytics telling that, okay, if you change the operators, or if you give more training to the operators, your performance can be improved. So those are the kind of prescriptive analytics that can be deployed in these kind of scenarios. So the various methodologies or the tools which are used, its optimization models can be used for the prescriptive analytics. So you can do the event simulations. You can do some simulations and find out, okay, if the scenarios are like this, what will be the outcome? And kind of what if analysis can be done. You can change the parameters. You can see what will be the output if you change the parameters in some particular methods. And then you have the kind of digital twins. Digital twins are nothing but it's the mathematical modeling of a system as such. So if you're taking a boiler or a HVAC system, so you can just mathematically model it. What are the different parameters that are involved in that system, and what is the expected output from that system? So you can model it perfectly, and you can make it as a digital twin. And if there is any variation from the theoretical output which you have computed and the actual output, then the system raises some alerts. Okay, and then finally coming to the generative AI, how it can be used in decision making. So these are the ways in which you can deploy the Gen AI into it. Like the conversational analytics, you can just ask questions in plain English and get the instant feedback. And auto summarization kind of thing. And by the way, Gen AI is much more used than the visualization or the dashboarding in industries because it is much easier to adopt. But even though it is used, it is not much encouraged because usually in industry people want explanations or they want a clear-cut understanding of why it happened, or they don't want a kind of a black box kind of a situation where they don't know or why the model predicted like that. It's not very clear, so they don't want such sort of a situation, and they want everything to be very clear, and that is the reason why it is not much encouraged. But though people are using it for the auto summarization, anomaly explanations, and all. And usually it works best with unorganized, unstructured kind of data. So in industries, other than this structured kind of data, which comes out as a time series, which comes out from these machines, PLCs, and all, there are a lot of the other documentations like the manuals, the product manuals, the machine manuals, the documents which they themselves have created over a period of time. A lot of such documents are saved. So if they want to summarize or if they want to get some insights out from that, so the Gen AI is the best thing which can be deployed. Okay, and when it comes to the manufacturing, they deploy a system called RAG, or retrieval augmented generation. So this is a typical workflow of a RAG system where a manufacturing facility's own data itself is used for generating something out from it, rather than it hallucinate. So you just provide the data of the manufacturing facility itself, and train the system so that it gives answers, much relevant answers to your questions. So this can be something like your PDF and all those kind of things. So it is broken down into a smaller chunks, and it will be embedded, and that embedding will be stored in the vector database. And along with that embedding, so you store the relevant data also along with that. And then when a user is querying, that query also is embedded. It's converted into an embedding, and then the similarity search is done in the vector database. And once the results are arrived, the top not 10 or 20 matches, so that is fed into an LLM system, and the LLM system generates the answers, and it is used by the user. So in this way, a lot of relevant data of the manufacturing facility itself can be used for these kind of generative AI things. So instead of just the generative AI thing give you some sort of unrelated or nonsensical answers, you can just use your own data, train the system, and get the relevant data out from it. So just taking a summary kind of thing, this manufacturing plants, it generates a lot of data, and we have seen the 4 levels of analytics: the descriptive, diagnostic, the predictive, and prescriptive things, and what it can actually give, and the actionable intelligence what can be derived. And then we also saw about the RAG systems. And the major impediment in using these kind of systems in industry, it is the data itself. As we saw, this is the kind of raw data which is available from the systems. And while doing the analytics in here, so we just converted that to so many different data sets. So this was the initial data set on which we worked out. So this is the initial data set which we worked out. And if we see the other data sets which are derived out from it, so maybe a OE3 or OE kind of thing which is derived out from it. So this is the derived data set which we actually derived from the original data set. So this kind of and we could derive this because we have a beautiful KPI defined, that is the OE KPI defined, and we know for calculating the OEI, the availability, performance, and quality is what is required. So and that is the reason why we could make such sort of a table and make some beautiful visualizations and get some meaning out from this original data. So making or pre-processing this data in a meaningful way, that is the much difficult thing in industries. So it's not the lack of data. They have plenty of data like this, and this is just one example. So similarly, they have the data from many of their sensors. They have the data from their energy meters, the consumption related stuffs. And plus, another important thing is whatever it comes from the machines, it is not of much use if the context is not clear. So here in this data set itself, we have some context which we derived. If you look at the second one, we have taken the context like we just just divided that time scale into 3-hour time scales. So every 3 hours. So this is just every 3 hours. We are not we are discarded all the other things. We are just accumulated all those things into a 3-hour thing, and so that we can make meaningful analysis. So this is one context which we are derived out from the time scale itself. Similarly, only another one context. This is the another context which is available. So similarly, we can have context like who was the operator. The operator name we can actually take in. So we can take in the context of shift, which shift it was getting manufactured. So that one created another data set in which this is actually a shift-wise data set. So we are creating more context so that the analysis can be much meaningful. So here it is shift-wise. I added another context to it. So this context also, it is derived from the timeline or the time scale. So similarly, the more the context, more richer it is going to be. Your data is going to be much more richer, and the analysis that is possible out from the data, that's also going to be in much depth. So here it is just one dimension which is just added into it, or the context which is just added into it. So similarly, you can have many contexts, and the main crux here is actually the defining the KPI itself. So what KPI you are going to define, how beautifully you can define a KPI, the better it will be for your analysis part. Okay, and so the call for action is like like this. You can the OE is just one. So like this, you can have many other areas where hello. Okay. Meeting. So it's basically like you need to identify areas where in industries you need to identify areas where you have the data or where you can collect the data, and that data can be utilized for this kind of finer analytics. A lot of things are left unexplored, like you have the vibration data which is coming from many machines. So vibration data is collected in millisecond granularity, or maybe 5,000 hertz or 10,000 hertz. That is frequency in which the vibration data is collected. And the vibration data, if that is converted to maybe a frequency scale, like if you are doing a fast Fourier transforms on the vibration data, you will get the frequencies and the amplitude, and then it is much easier for you to analyze it. So that is one kind of data which is available in these industries, the vibration data. And then they have data about if it is a process industry and all, they have data about the temperatures, the pressure, the vacuum that need to be maintained, the various cycles it needs to pass through, and the duration in which this process needs to be completed, or the duration through which the input needs to pass through that particular kind of a process. So these are the typical kind of data which is available from these kind of industries, and it's like a lot of things needs to be done. a lot of kind of academia industrial collaboration is required, where the data can be given to this kind of data scientist, or the people who can do the analytics, and they can come up with these kind of analysis, like where there are scope, where there is still scope for improvement. What are the parameters that can be fine-tuned so that you get a prescribed level of output. So a lot of work needs to be done in this sphere. It's not the problem with data. Data is available. So it's how you are going to make a beautiful context to this data. And without this context, just analyzing some numbers will not give much meaningful insights. So more the context, more beautiful your analysis will be. So the focus, the industry, from the industry perspective, the focus should be on to add more and more context to the data which is already available there. And now maybe if that data can be shared with academia, like a good results can come out. So this is all what I have today to share with you. So if you have some sort of questions. Any questions or any particular thing which I can comment upon, please be open to ask.
Any questions? Participants, please respond.
No, ma'am.
There's one question in the chat box.
Yeah, this is actually it's a good question. Like the many of the data which industries collect, it is not actually useful for decision making. So how can industries ensure means first of all, see why the data which industries collect is not useful. That is because there is not much pre-processing that is done on the data, and plus, some of the context will be missing. So it may be some temperature data, but they don't know from where that temperature is collected, or to which part of the process it needs to be related to. So if that context is missing, then this data is not suitable for decision making. So it's like you study that data further in detail, and you understand it better, and if you can add some context to it, definitely that can be used for decision making. Otherwise, it's going to be some kind of a junk data.
Okay, any more question? Participants, please respond. Any more question? Okay, sir, there is one more question in the chat box.
See, about the roles and job profiles essential for this data driven in manufacturing environment. See, in manufacturing companies, So you need to understand the domain in much depth. So that is one important thing that is required. So if you just ask me about the roles for this kind of the data-driven analysis kind of thing, like no, see the in many companies they have these automated systems, okay, and they have collected the data also they have collected, and they would have subscribed to some sort of Power BI or Tableau or some visualization tools they would have already subscribed to. But in many companies, what they find is they lack resources who can actually uh, explore this data in a meaningful way. And the data exploration, it's difficult because now, unless you know the domain and unless you know what is actually essential and what is uh, useful for a decision making, or how the decisions are it's taken, like there is a flow to every decisions. So unless you understand that, it will be very difficult for somebody to make meaningful dashboards or meaningful analysis out from it.
താങ്ക്സ് പറഞ്ഞു കഴിഞ്ഞിട്ട് മിസ് അടുത്ത എല്ലാവർക്കും കൂടിയുള്ള
So the main job profiles would be the data analytics profile itself in manufacturing industries. But for you to grab that role, you need to understand that domain in much deeper sense. And plus a knowledge about the kind of statistics and the various kind of the number crunching methods and all those things. If you know, that would be much better.
If any other queries, please put it in the chat box.
Any more question? Okay, thank you, sir. So on behalf of Department of Computer Science and Engineering of TocH Institute of Science and Technology, I sincerely thank you, sir, for your insightful session on data science for decision making. Your explanation of how the data is transforming the modern manufacturing, along with the concepts of descriptive, predictive, and prescriptive analysis, is provide a valuable clarity to our participants. The live visual demonstration truly enhanced the learning experience by connecting theory with practical applications. So we are grateful for the time you dedicated and the industrial perspective you shared with us today. Your session also inspired our participants to delve deeper into the world of data science. So thank you once again, sir, for contributing to the success of day one of our FDP. So we look forward to the privilege of hosting you again in future. Thank you once again, sir.
Thank you. It was a privilege actually participating in this FDP session. Thank you once again for inviting.
Sir, here is one more question again. Sir, there is a question like whether data analytics significantly improved operational efficiency in a manufacturing unit. Can you please address the question?
Can you repeat that once again?
Okay, sir. Whether the data analytics significantly improved operational efficiency in a manufacturing unit.
No, it's not significantly increased anything because see, a majority of the manufacturing companies in India is not yet come into this kind of analytics sphere. So it does not significantly improve, but people are trying. Many companies are trying. and maybe some of the world-class companies, I would say, like maybe the Mahindras or the Marutis, the Hyundai and all, they would have done something. But the other companies which we usually hear about, so those companies still they are struggling with the data whatever they have collected, and many companies have put in sincere effort in collecting and storing this data, but not much is done in analyzing it, and not much is done in doing something useful with this data. So to answer straight away to the question, it's like industry has not yet benefited out from these kind of the data analytics or the data science things which has recently come up.
Thank you, sir. Thank you for your patience.
Sir, actually, there is one more question from Amala George. Could you give an example where data analytics significantly improved the operational efficiency in a manufacturing unit?
See, like I can tell one example. In process industries, we have many companies, especially in Kerala, we have many companies which are into spices processing. A typical example would be this curcumin extraction from turmeric. So there are many companies in and around Kochi which does that. But the major problem which they face is the yield, or the they are not able to predict the yield. One lot of raw material, it will be coming from one part of this country, it comes from Andhra Pradesh, and some other lot which is coming from Tamil Nadu, and some other lot which is actually coming from Kerala. And this raw material, there is a huge difference in the raw material. That is the turmeric itself. The turmeric which comes from Andhra is not same as the turmeric which comes from Tamil Nadu, which is not same as the turmeric which comes from Kerala. So because of that, they need to constantly vary the process parameters in a way that they get the constant output always. But that is humanly it is not possible. The most experienced guy in the factories also, they struggle to adjust these parameters so they get the constant output. That is actually the curcumin extract. So that is one place where some of the companies, what they have done is they have modeled it. They have made a statistical model of all these process parameters and the quality of the raw materials. They graded the raw materials into several categories. So they know exactly, or the machine already knows, the statistical model knows exactly how to adjust the process parameters when a certain a grade of raw material comes up. So some of the companies, they have done this in an automated way also, like the process parameters, it get automatically adjusted when a particular grade of raw material is fed into the system. So this has actually increased the yield a lot. And yield means it is directly related to their output or the performance of that company. So that is how some of these techniques, some of these data analytics techniques has impacted these sort of industries. So statistical modeling is it's a very, very beautiful thing that can be done in many industries across the sector. They call it as digital twins. If they have a process line, so they some of the parameters are already known, but some of the parameters it needs to be modeled, a mathematical. They need to cover it with a mathematical model kind of thing. Typically, it is going to be some very easy kind of regression models what these companies are doing, but that itself is yielding the results. Instead of going for some big AI models and all, in none of these companies they prefer these AI models because they want some sort of explanation which needs to be given for the particular set of behavior. So in deep learning and AI kind of things, the explanation is it's very difficult. So they go for the explainable models. That is basically the regression models. Any other questions?
Any more question from participants? There is one question from Bhagya Kulkarni. Which are the tools we can teach to students for analyzing which can be useful for them in future?
See, when talking about the tools, like, we need to see this in 3 or 4 different ways. Like, analysis is one part of it, modeling is one part of it, but then you need to have this data in place. Like, in some of these industries, it's going to be very huge amount of data you need to manipulate with or work with. So data engineering is one area where you need to actually focus on. So that is one thing. Data engineering, especially, it is all based on, you can do it in Python. So a knowledge of Python is an essential thing if you are looking at this sort of data engineering part. And then coming into these analytics things, any of the any like this kind of visualization tool, a Power BI or a Tableau, and this superset is much adopted in big companies nowadays, because this is actually an open source. Power BI or Tableau, it's costly, because they have got annual usage charges as well as the license fee, and all those things are there. But this superset is actually it's an open source, and for like, doing or analyzing the time series data, superset is much better. So it will be very nice if students are actually taught this kind of open source visualization tools. And plus, another thing is, like, there are a lot of tools which are available for doing what do you call the machine learning part of it. So you can make machine learning pipelines, you can apply various models onto it, you can analyze it. There is one tool called, that is also an open source tool, one tool called Orange. So Orange is it's a very small tool, but it's pretty interesting, because many of these companies, manufacturing companies, they can play around with their data. So the domain experts, because simply somebody going there without knowing the domain, they cannot do any wonders over there. But the domain experts, the people who are already working in that company, they can play around with their own data using these sort of tools like Orange.
Thank you, sir. Thank you for addressing the query.
Thank you.
So I think there is no more queries left to answer. So here come the end of the first day of our 6-day online FDP program. On behalf of the Department of Computer Science and Engineering, TocH Institute of Science and Technology, I extend our heartfelt gratitude to all of you for contributing to the success of day one of the AICTE ATAL online faculty development program on next-gen intelligence, HPC, applied AI, and data science. We sincerely thank our esteemed speakers, Mr. Praveenam Vijayan and Mr. Sherry Thomas, for their insightful and enriching presentations. Your expertise and valuable knowledge have greatly enhanced our understanding for supercomputing, AI, and data-driven decision-making. We are truly grateful for the time and effort you dedicated for this session. We also express our appreciation to all the participants for your active engagement and enthusiastic involvement throughout the sessions. Your presence and participation made the discussions more meaningful and productive. Thank you once again for all. We look forward to your continuous support and active participation in the upcoming sessions of this FDP. Thank you again.
Thank you.
Okay, thank you all. So we can meet in the next session tomorrow.